Let's look at solving quadratic equations. I want to look at one quadratic that's not absolutely the simplest, and I want to use all three of the standard methods on it, compare and contrast. So probably our most familiar method is factoring, and I'll do it first because it's familiar, but I really want to highlight it doesn't always work. Don't assume things factor. And so don't spin your wheels if you're trying to factor and it doesn't seem to. You might want to try one of the other methods. And I purposely did one here where the factorization is not super simple. And because both of the quadratic leading coefficient and the constant coefficient are kind of interesting, the grouping method works well. So 6 times minus 15 is minus 90. And so I'm going to try to separate out a minus 1x into two numbers times x, and those two numbers have to add to minus 1. And so one's going to be negative, and multiply to be minus 90. I'll pause on this probably. And it's going to be minus 10x plus 9x minus 15. Okay. Now what can I take out of the first two? I can take a 2x, and I get a 3x minus 5. And then hopefully, now if I take a 3, 3x minus 5. Oh, 5. Groovy. Okay. And so I've got 2x plus 3, 3x minus 5. Okay. So how does that help us, right? So let's go back to the original equation. It is so crucial that I've put everything on one side and this is equal to 0, because what I'm using here is the zero product property. If you're solving an equation, don't factor the left-hand side. If there's anything on the right-hand side, it won't be very useful. It will be almost useless. But if this is 0 and you have factored the left-hand side, either 2x plus 3 equals 0 or 3x minus 5 equals 0. And it's absolutely crucial, never do this with something that's not 0, because it's just not a property of numbers. When two real numbers multiply to be 0, one of them has to be 0 at least. But this is not true if you're multiplying to 7 or 2 or minus a third or something like that. Okay, and then these guys solve pretty easily. Okay, x equals minus 3 halves, and this is 3x equals 5, x equals 5 thirds. So the solution set is minus 3 halves and 5 thirds. Okay, so that's one method. It worked here, but it wasn't trivial. And yes, and I contrived this to have this factorization, and so it did work out with pretty simple rational numbers, but that is absolutely not guaranteed. Okay. All right, let's do completing the square next. That's something we reviewed at the start of last semester, but is usually the least familiar. It's going to look a little bit challenging here because of the 6. And so we're going to have to, the fractions are going to get a little more front loaded here. Okay. This is different from how the book expresses this. I really think it's important that completing the square, just like factoring, it doesn't have to be in the context of an equation. We are using it in that context, but it's really manipulating and rewriting an expression. And so I really am just going to take this expression, I'm going to do a few steps to rewrite it, and then I'm going to put it back in the context of an equation. And I'm not going to allow myself to use any of the techniques I would have on an equation, like add something to both sides or subtract something from both sides. What I'm going to do first is simply factor out the 6 from just the interesting part. The constants are going to be the easy part. This guy's going to be a spectator for most of the time. But the key is I'm trying to rewrite it without an x to the 1 power anywhere. That's going to be much easier, and I'm going to use a memorize step next, but that only works if I've made this guy into a 1. And that's why I'm factoring this out. Now, the next step involves two sets of parentheses, because these parentheses are just saying, here's the field of play for this guy, and I'm separating it out from the 6 and the minus 15. And then the key thing is, that didn't work. I'm going to divide this number by 2. That's the one thing you have to memorize. And then I'm going to say this, it turns out that this is going to be really, really similar to this guy. It's almost right. So let's do a little check. You shouldn't have to do this once you practice it. Let's just FOIL that out. I claim it's going to be really, really close and easy to fix. It won't be quite right, but it'll be easy to fix, right? Let's just remind ourselves of a plus b. This is one reason. Oh, actually, a minus b. They're very similar. This is why one big reason why we want to have these perfect square trinomials absolutely memorized. Aha, when I FOIL out a difference squared, I'm going to get this squared. Hey, that's what I want. I'm going to get 2 times this, and that, let's just write it out. So I get the x squared. I get 2 times x times minus 1/2. Hey, that is 1/6 times x, or there we go. Okay, and that too, anticipating kind of undoing that too, is why we divided this by 2. Now the unpleasant thing is I get a plus 1/12 squared, which is plus 1 over 144. This will always be a plus, okay? And that means this is really, I just accidentally added something in that I didn't want. Easy to fix, I just subtract it off. So the quick way, if you practiced at this, you don't have to redo this every time. You just know that it's gonna match these guys, guaranteed, but it's gonna add this squared. Oops. It's going to add plus this squared, no matter what the sign is here. And so I have to kill that off immediately by subtracting it. Now this is still hanging out over here. Okay. All right, now I'm going to just, I had taken that 6 out so I could do that in a very standardized fashion. Now I'm going to distribute the 6 back in. But I absolutely don't refoil this. The entire point is to have this in this form. Do not mess with it. Now, 6 over 144, that cancels down to 1 over 24. Not too hard. Still a minus 15. Okay. And I should probably combine this together. And so, now they're both minus. Really be careful with your signs here. Okay. And okay, so 15 times 24, I'm going to multiply common denominator, just like other things we're doing lately. 15 times 24 is 360, so I get a minus 361. The numbers are getting a little big, but that's life. And we're going to see that 361 in a very interesting way in a second in our last method, the quadratic formula. Okay. Okay, that's about it. That's the completing the square part. And it's just rewritten it in a way that's very, very useful, where the x only appears once. We're going to see this is very useful, for example, for graphing a quadratic function. And so now, okay. So now put it into the equation. Okay. So we're now going to be able to rewrite that equation. Okay. Now, how do we work with this? A big mistake here is people will refoil this out because it's going to look sort of more familiar. But the point is that this is a really good form for this kind of equation. I can just start stripping stuff off from the left-hand side to the right. I'm going to add that constant. It just moves over as a plus. I'm going to divide by 6. I like to think of this as like an onion, stripping off layers of the onion. Okay, we get 361 over, oh, it happens to be 144 again. Okay, and we could have actually done it where the 144 was kind of sailing through, but that's sort of anticipating stuff. Okay, now here is where it's liable to get ugly. I contrived this, and we know already that the solutions are going to be nice from doing it the other way. I contrived this to be nice. In general, this is going to be some fairly random number, and you're going to get the square root of that number. And you might be able to simplify it a little bit. Now, here, it turns out, well, so you're always going to get plus or minus the square root of this guy, always. And then the question is, does it simplify? That 144 hopefully is familiar. It turns out 361 is 19 squared. Again, I contrived that. And so it's actually 19/12. Okay. And so one way to write the solution is 1/12 plus or minus 19/12. That's actually kind of a nice way to write it. It says they're sort of symmetrical around 1/12, and you can go either to the right by 19/12 or to the left. But we'd often want to just cash those out separately. So that's either 20/12 or minus 18/12. Both of those simplify, not surprising. This is your 5/3, and this is your minus 3/2. And so that's what we had. So in this case, this one I think is a little more intense than the factoring, but the factoring, we had to be a little clever. Here, we didn't have to be clever at all. The numbers just got a little bit more complicated as we did the process. But the thing about completing square is it's much more powerful than just a method for solving equations. Doing this rewrite of taking this version of a quadratic and rewriting it this way, we're going to see benefits for that over and over again in different contexts. And I wish we did it every day. Honestly, we won't, but it's good to see it come up over and over again in interesting ways. Now, last method, quadratic formula. The quadratic formula is actually proved by completing the square in general, and so it's going to look, it's going to have the same pieces, but there is a value to just having a memorized formula. But if you, I don't know if I'm going to take the time to do this. We'll see. It doesn't take a lot of time. But if you just complete the square with a general a, b, and c for the coefficients, this is what you get. And this is just kind of a slightly simplified form of what you get. And I want to highlight the discriminant here. This is, again, something that's really, really useful to calculate for any quadratic, even if you're doing something other than solving. It's certainly most important for solving. That we call it, like, often big D. This is a really good thing to calculate even first. When you first look at a polynomial, a quadratic specifically, there's versions of this for higher polynomials, but we never do it. Okay, let me just remind myself exactly what the polynomial was. Okay, so that's going to be -1 quantity squared is a +1, and then -4 times 6 times a -15. Okay, 1 plus, hey, 24 times 15. That sounds exact. That's really familiar. Oh my God, that's that 361. Okay. Now, what's so important about the discriminant? When it's positive, that means we will get two distinct real roots. Why is that? Because if this is positive, the square root will not generate any i's. And because it's not 0, the plus or minus will give us different answers. It will modify the minus b in different ways. We'll get two distinct real roots. Okay. And we can say more. If it is a perfect square, so if you start out with something with integer coefficients, which is typically where we're at, although for science and engineering, no way. It's very, they could be really weird coefficients. But here, most high school math problems, we're going to have integer coefficients here. We're not going to get any weird numbers from a minus b. We're not going to get any weird numbers. Nothing weirder than a rational number, a fraction from dividing by 2a. But the square root is what could create ugly square roots. But if the discriminant is a perfect square, we'll get rational solutions. And of course here, we've already seen we get rational solutions, and that's related to the fact that 361, and I contrived this, is 19 squared. Okay, so even if you don't want to know the solutions exactly, calculating a discriminant really early on is a very good thing to do. In particular, maybe we'll look at other examples. If this hadn't been a perfect square, the factoring method would have just not worked unless we were put in really weird irrational numbers, and nobody tries to do that. Okay, so now let's just plug in the whole thing. So again, I think we'll practice focusing on the discriminant at least a little bit, because it's so useful. Okay, so 2a is 12. Oh, look, there's that 12 denominator we got from completing the square. Minus b, because b is minus 1 here, that's a plus 1. Plus or minus root, and I already calculated the discriminant and even its square root, and there's that plus or minus 19. Okay, so notice it's getting something that's basically in the same form as the completing the square answer, and we've seen that that's 20 over 12 or minus 18 over 12, and again, that's 5/3 or minus 3/2. Okay, bit of a long video doing 3 methods in one, but I wanted to compare and contrast. Completing the square often is the least favorite of the 3, but it's actually the most powerful in a lot of ways, and so I really want people to know that. If you want to just get the numbers and grind them out, and this will always work, completing quadratic formula. If you want a method that gives you another perspective and does work in nice cases, good old factoring as well.